Hey everyone! Before we start looking at specific types of circuits and how to apply things like Ohm's law to the variety of circuits that exist, we want to make sure we understand how electrons are flowing into a circuit. So that's going to be our first job. Quickly make sure we understand what's happening when you plug a battery into a group of wires, how those electrons are moving. Okay? To really talk about what's really going on, what's actually happening, it's important to point out a couple misconceptions that a lot of people have when it comes to batteries and circuits. The first misconception is that the batteries are supplying, they are the source, they are what's giving electrons to the circuit itself. Okay, without the battery, there are no electrons. This is the common misconception. There are no electrons. You plug in that battery, its job is it's the supplier of electrons. And that simply is not the case. Related to that misconception is another one, which is that the wires in a circuit, they're like hollow tubes, and the electrons are flying through those tubes almost like a water slide when, people are shooting through those water slides. Both of those thoughts are incorrect, and it's going to lead you to some incorrect physics and to more misconceptions, more complications when you're trying to visualize or understand what's happening. First of all, to discuss that first misconception, the electrons, they're just parts of atoms, right? They already exist in things that are made up of atoms. Wires already have a bunch of electrons in it. Light bulbs have electrons. Switches and gears and motors and graphic processors, all of them already have electrons in it. Okay, there is not an absence of electrons, and you have to have the battery to get some. Really what's going on relating to the second one is that with all these electrons already in place, what the battery does is it's giving electrons energy, additional energy, to start moving in a particular direction. Okay, that's the role of the battery, to give energy to those electrons that already exist to start moving. So, next slide. Couple diagrams here. We're going to go through them one by one. This is kind of the bad diagram. If you think of this hollow tube here, and then electrons just flying by one at a time, if you imagine my highlighted pointer. This is not what's happening. One electron flies by. Then here comes another one. Here comes another one. That is not occurring. Don't think of these wires as hollow tubes. Here's a good example. This first one here, I'll label it A and B. Okay, this next diagram A, this is a wire that's not connected to a circuit, just a wire all by itself, kind of a piece of it. Okay, those blue things, those are the electrons. We know there's already billions upon billions of electrons in every square inch of wire. Okay, and they're just jumbled around. They have some energy even already. They're just zigzagging around atoms. They're maybe migrating a little bit in random directions. When you connect a battery, okay, obviously we're not seeing the full circuit here. When there's a negative terminal on one end and a positive terminal on the other, what the battery is doing, it's giving these electrons guidance. Now they can all start marching more or less in a particular direction, in this case to the right. Okay? Electrons weren't added in. Okay, we didn't have this hollow tube. The battery just makes it so those electrons start drifting, start marching in a particular direction. Okay, remember, when we talk about voltage, what that means. The battery is what's giving the things voltage. And in our class, the battery is usually pretty much giving the total amount of voltage. And voltage is the amount of energy every unit of charge is given. Each electron is given a certain number of joules of energy. Okay, voltage is how much energy each coulomb is given. Well, this bullet point right here is often confusing. Okay, that energy has to be used up by the time the electrons go around the circuit. For example, let's say I have an electron right here. It's given a certain amount of energy because the battery is connected. We know that electron is going to flow counterclockwise through this light bulb, like that, back down, through, and to the other terminal. The battery gave the electron energy, and that electron must use up that energy by the time it makes it all the way through. And that's not intuitive. Why does the electron have to use all that energy up? How does it know? That's a question I get a lot. How does it know to use up that energy? The best way I can show it is with an example of the ball on a cliff. I've talked about this example before. So let's look over here. I have this cliff, okay, in this orange brownish pen color, and I have this red ball. And first, at time 1, the ball is at the top of the cliff. I let the ball go, it falls, and it's obviously falling down the cliff, and it's just about to slam into the ground down here. Well, measured from the bottom, there's some amount of height. So if there's some amount of height, this ball must have some gravitational potential energy. I don't think any of you would argue with that. Gravity would make that ball fall downward, so it has some type of energy. Well, by the time that ball finishes falling, finishes flowing through gravity, it loses more and more gravitational potential energy. And by the time it's finished its path, it's finished its flow, down here, relative to the ground, its GPE is 0. It lost all that gravitational potential by the time it's finished its path. Same thing with the circuits. The electrons use up all their electric potential energy by the time they finish their path flowing through the circuit. Well, where did that energy go? We know in the ball example that it gets turned into like kinetic energy. Okay, GPE goes down to kinetic energy. Where does the energy go in the circuit here? Well, it must go into something. If there's a light bulb attached, that energy is going to be deposited by making that light bulb shine. Aha, give us light energy. So that electric potential energy is lost, giving it gravitational potential. I'm sorry, that electrical energy is lost, giving up, or now giving something another form of energy there. Okay? Likewise, the ball can't fall halfway and then just stop, because gravity's still pulling on it. Kids might ask me like, oh, how come the electrons know to keep going? Why don't they just use up all their voltage right here? Well, that doesn't make sense. The ball's not going to use all of its gravitational potential energy here if there's nothing else impeding it. Okay, it's going to keep on flowing downward until it used up all that gravitational potential. The 9-volt battery, it uses up all that extra 9 volts when it gets all the way through the circuit. So it must use up all that energy. It's really just an example of conservation of energy. If these charges could go like, ooh, 9 volts, didn't use up any. Another 9 volts, that's 18, didn't use up any. Ooh, another 9 volts, 36. Well, that would violate conservation of energy. Electrons would be getting more and more energy just by going in a loop. We would have unlimited free energy that way. That doesn't work. Okay? That energy has to be converted into another type. Last thing I'll say is if you've ever heard of something known as a short circuit, if I imagine the light bulb and this wire are gone, and instead the circuit is just like this, it's just this red wire here. Short circuits are when electricity takes a path you don't want it to. Normally it means it's skipping something that would use up the energy. This is very dangerous because those electrons must use up the 9 volts of energy, however much energy each electron is given. If there's no obvious light bulb, those electrons are going to deposit that energy as like heat into the wire, or as heat maybe back into the battery. That's what makes things heat up, possibly melt, okay, possibly catch fire if it's in a complex computing system. Short circuits are bad because of this idea that those electrons must use up all the energy some way, somehow, before or by the time they finish their circuit. Okay, those are the basics about how electrons are flowing through a circuit. Next, we'll be applying it to the different types of circuits.